Okay, see Lindelof videos, differentiation of logarithmic functions and exponential functions. So here's this problem that it actually looks like hell. I looked at this, I said, I'm not even sure I want to take a look at this problem. And then I looked at it another minute and realized this is actually really easy, but it looks terrible. And that's exactly what's going to happen to you on the AP exam. So look at this. We have our function is equal to e to the 5x to the fourth over e to the 4x squared plus 2. And I'm like, holy crap, what is that? Is this like some kind of quotient rule problem or whatever? And I realized I can do something here. So think all the way back to algebra 1 and 2, rules of exponents. If we have like bases, a, and we have a to the m over a to the n, all we do is take a to the m minus n, right? That's algebra 1 and algebra 2 stuff, so hopefully we have that. So that's the rule I'm going to apply here. So this is not me differentiating yet. This is me applying my rules of exponents. So here's my rules of exponents here, and I'm going to say my base is e, because this is e, this is e. The top one is 5x to the fourth, and I have to minus the bottom one, and the bottom one is 4x squared plus 3. You see I put these parentheses here because I have to subtract the whole thing out, not just the 4x squared. So I did have to be a little bit careful about that. So I'm going to go ahead and rewrite this one more time, and then we can get on to differentiation, right? So e to the 5x to the fourth minus 4x squared minus 3, right? That's me distributing this negative sign here and here, right? So that's how I got there. From here, this gets really, really easy, right? We know that the first derivative of e to the x is e to the x, and therefore the first derivative of e to the f of x is e to the f of x, but also times the derivative of this inside piece. So first thing I'm going to do when I differentiate is just rewrite this piece and say, okay, I know part of the first derivative of this is just itself. So there it is right there, right? Right? And then it's times, so I'm going to use parentheses for multiplication if you don't mind, times the derivative of this thing. So I'm going to differentiate this thing by part. The derivative of this piece is it's 20x to the third, isn't it? So 20x to the third, right? The first, that's this part. I'm going to take the derivative of this part right here. So I'm looking at this part right here. And its derivative is negative 8x, isn't it? And the derivative of negative 3 is 0, so I don't need to write anything there. So this is my answer. So you're like, Lindelof, should I distribute this inside? Hell no. Right? Thank God we're in calculus, and we don't have to clean up every little thing we do. So this is probably simplest form. Look, I hope this is helpful. If anything, I really want to tell you guys is, you see this stuff, especially when it comes to log functions, people tend to freak out, and also trig functions. Just take a second before you start moving, before you start writing an answer, just look at it for a second and ask yourself, what do you have? So I mentioned to you that I got kind of turned around when I first started looking at this. What helped me was this. I was like, oh, this has a base of e, this has a base of e, and therefore look, e to the m over e to the n is e to the m minus n. I can use this rule, and right, because once I got it in this form, once I got to here, man, I was good. It was just getting to here that sucked. So I hope that you'll really take your time and think your way through stuff and think about which rule you're going to be using and what other rules, algebraic rules, do you know. God, I feel like I just rambled, so I apologize. If you have any questions or comments, let me know. And if you haven't already subscribed, please do. I appreciate it.